I am a university professor at Northeastern. I am in the Mechanical and Industrial Engineering Department. I'm also head of DAP's Research Lab, Directed Assembly of Particles and Suspensions. We try to tailor material microstructure to find emergent properties from that. That has put me in touch with a lot of industrial partners and funders over the years, and through that experience, we've developed a keen awareness of pain points that occur in industry and have found a few ways to really provide a new technology. Yeah, my mind goes to a carbon fiber product at Boston Materials. We worked with a boutique performance ski company and embedded our Z-axis fiber in the ski and found that not only does it improve overall stiffness, but it delivers anti-vibration to reduce ski chatter, which is something that occurs when you're running over packed snow and your ski starts to vibrate. These skis with Z-axis fiber do not. Yeah, absolutely. The first is Fortify. Fortify is an additive manufacturing company founded in 2016 with my PhD student Josh Martin and several other Northeastern students. Fortify's mission is to commercialize the materials, the hardware, and the software for printing particle-filled photoresins. Adding functional filler to the photoresins can enhance mechanics, benefit thermal performance, and enable RF behavior. But at the same time, when you add functional filler to these 3D printing resins, it devastates your rheology, it challenges homogeneity, and it complicates overall photokinetics. And so Fortify has really made a business of building the hardware, the software, and the new materials that are enabled by those two to have robust design, onboard mixing, advanced software approaches, and print parts out of filled photopolymers. Fortify's at the Series B funding stage, has about 75 employees at their headquarters in Boston, and are really focused on commercializing materials, hardware, and software. A second spin-out, Boston Materials, was also founded in 2016 with two Northeastern students, Anvesh Gurijala and Michael Siegel. Boston Materials has several product lines that leverage that Z-axis carbon fiber material that's made up with 100% reclaimed feedstock. And so Z-axis fiber combines not only the high performance but also that sustainability and brings circularity to the carbon fiber industry for the first time. Boston Materials is at the Series A2 funding stage and has about 25 employees at their headquarters here in Billerica. The third is a newer company called Fourier. Fourier is a thermal management solutions company that brings extraordinary thermal conductivity of phenolic ceramics to the aerospace, renewable, and EV industries in a massively scalable way. Specifically, Fourier has developed a manufacturing paradigm that enables highly detailed technical ceramics to be compression molded in minutes rather than the incumbent methods of casting and sintering individual parts which require days. Fourier has just founded this year and is in early stage. Me and Jason Hoffman-Bice are trying to approach the market. In academia, we're told that our breakthroughs take about 5 to 10 years to commercialize. In my experience, that's about true, but the 5 to 10 years is full of really hard and dedicated work. And, it assuredly helps to be a little naive about it in the beginning. The inspiration for our first launch in Fortify was really twofold. First, we knew we had a meaningful breakthrough. I would give seminars at industry partners at the companies. They would ask the right questions, they would lean in, they were clearly excited. We were answering their current pain points. But found that nothing really happened for about 2 years after our breakthrough. No licenses, no joint development agreements. And assuredly, in part, this was because the technology was complex. enabling light-based additive manufacturing of highly filled composites. This was tough tech, and it became clear to me that we were staring at the infamous technology valley of death. How do you take an idea from proof of concept to a validated and de-risked product? For us, it was 5 years of hard work, and we were the only ones willing to put in the work to bring it from that concept to a proven product. The second main thing is the new Northeastern students that I was working with. Josh, Carlos, Scott, Andrew, Dan, and Phil for Fortify, a big founding group of students. Anvesh and Michael for Boston Materials. Jason Hoffman-Bice for Fourier. These groups of students were inspiring, they were ambitious, they were ready to learn and ready to sweat. Startups are about 50% technology, and the other 50% is about the people. You need both. And in each of these cases, we had both. What was left to do was just everything. And my experience so far, every company launch is very unique. There's no single approach. There's no common dominant challenge. For Boston Materials specifically, a really big challenge was understanding the path to market in a very tough landscape. The carbon fiber industry is made up of a few Goliaths. These incumbents, the path to market is long. There's significant qualification required. Overall, pretty daunting. You really have to hone your minimum viable product, your MVP. You have to find some traction. You have to really focus on early adopters so that you can stepping stone your path to market. And we had to adjust early on our aerospace ambitions to include sports and consumer electronic industries, due in large part to that faster adoption cycle. We're now making headway in aerospace as well, but likely wouldn't be around today still if we didn't broaden our aperture to include and find those fast adopters. The startup really needs to get that MVP right. Leveraging advisors and doing customer discovery is really essential there. And being willing to fail quite a bit. It took Fortify a long time to land their first seed round, 40 to 50 pitches with no before we got our first yes, and haven't looked back since. Yeah, separation here is important. My research lab cannot be used to unknowingly create value for those companies. It's not fair to the graduate students. It's not fair to the university. There are opportunities for synergy where my lab is uniquely positioned to run certain experiments or provide certain analysis. The approach that I enact here is really to compartmentalize. From the university perspective, my spinouts are third-party companies. From the spinouts perspective, my lab is a third-party lab. And of course, I understand the IP and the value of that IP on both sides, but I need to serve as the gatekeeper there. It's tough, but it's important. If a PhD student has a breakthrough that creates IP, the spinouts can't find out about it until the university properly protects it. I manage the conflict of interest through a guiding plan that is in coordination with my department chair and with the universities and university principals. Yeah, for me, the toughest part was really related to language, being able to speak the vernacular of the startup from LLC to C Corp, understanding what vesting schedules were, having NDAs in place and what clauses to put in those NDAs, when to actually get legal counsel. All of these are really quite intimidating to a first-time entrepreneur. And as we spin out a third company, I find myself going through the same conversations, the same learnings again this third time. It is a slightly different opportunity each time, and making sure you understand the full landscape and that you are fluent in that language is important. In my mind, incorporating doesn't have to be too large of an effort. We've launched as a LLC a couple of times, which doesn't require as much money or paperwork in the beginning, and you can simply convert over to a C Corp with a successful raise. The storyline for founding a company can definitely be ambiguous in the early days. Are we doing this? Are we not? Do we have enough of a signal from our customer discovery? Founding discussions represent really a change in the story to we are actually doing this. And with that comes the opportunity to see if you are truly aligned with your co-founders. You can learn about the motivations of your co-founders through those incorporation discussions about their life goals, both near and long-term, and about their levels of commitment. I think overall the right time to incorporate is when you're ready to have that discussion and when you've engaged in enough customer discovery to de-risk your concept of your first product. Yeah, equity discussions can definitely be challenging, really in the case of limited perspective. In my mind, it's important for the founding team to have as many conversations with advisors as possible. The advisors really allow you to understand that landscape, allow you to understand what balances work, what value individuals are bringing, and how that value is going to be developed during the founding of the company. There's many things to value, including the basis IP for the company, who is doing the boots on the ground effort, who has the network that exists, who is willing to network, and who has the experience and the skill set to get things done. All of these are important and merit value, and often have drive very different perspectives of what that value will be based on who is in the conversation. One thing that I really do believe in across the three companies is that it's important to put a single leader, a person that will bleed and sweat and work 60 hours per week in the driver's seat of the company and driver's seat of the cap table. The VC firms like to see this as well, in my experience. If the person doing a big chunk of the big picture work for the company to be successful is going to see a big reward, then you have alignment. And generally, venture capital firms like to see that alignment in both motivation and reward. Yeah, going that route was an easier decision for me. There was simply not an individual in the world that knew our technology at Fortify any better than PhD student Josh, or the technology at Boston Materials any better than my PhD student Anvesh. Both individuals showed tremendous dedication and leadership potential. They were both humble, which is unbelievably important. Said differently, they were ready to learn and didn't have fixed ideas. They were also incredibly tenacious. They would overcome challenges. Founding a company will be challenge after challenge, swimming that uphill battle against the avalanche, and you hope to end up on top. Supporting Josh and Anvesh to be the leaders was a natural extension of my role as their research advisor. Yeah, the true enabling factor there in the success of Josh and Anvesh was really the ecosystem at Northeastern. Northeastern has created a tremendous entrepreneurial ecosystem. The patent office here, CRI, has a smart approach to technology licensing that actually gets IP used. There are several incubators on campus, Origin, Idea, for example. We've used all of them every single time. There's a venture mentor network on campus that we have extensively leveraged every single time. There is a NSF iCore site on campus here that Mark Myers set up to enable customer discovery, which is crucial for new spinouts. Really, the landscape has enabled us. I've played very active roles at Boston Materials and Fortify. At Boston Materials, have been part of the team growth, also played the role of senior applications engineer for a year to be boots on the ground delivering effort. At Fortify, I was a director of materials for a year and a half, leading the R&D team and working towards material productization. In both cases, I was reporting up the company structure to my PhD students and learning tremendously from them every day. Today, I'm still engaged as scientific advisor at Boston Materials and at Fortify and interact daily with them. Yeah, Fourier is based on what turned out to be a bit of an experimental fluke in lab. We were observing a ceramic under temperature and pressure and saw thermoforming occur. Thermoforming in ceramics isn't a thing. Thermoforming is how we stamp our sheet metals or thermoplastics into complex shapes at huge scale. And ceramics are supposed to be slow, expensive, and painful. The fact that we are thermoforming ceramics is exciting and creates new opportunities. So I'm most excited about delivering our first set of thermoformed ceramics to early adopters in a pilot program that we've set up. We have customers engaged in that, and to see if we can prove our perceived benefit, understand our minimum viable product a bit better, and that would experience would really throw lighter fluid on the fire. Yeah, generally the university will allow a day per week in extracurricular pursuits. These roles went well beyond that as far as time commitment and involvement. And so I, with the university's guidance and support, was able to leverage a sabbatical as well as a leave of absence over the course of a total of 2 years to take a step away from my academic role and to be able to really invest the time required to have a meaningful contribution at the companies.